Hello, we're team7, proposing the topic category-infused relation-aware collaborative learning for aspect-based sentiment analysis. First, in the introduction section, we will talk about our research that was announced in the existing proposal presentation. There are hundreds and even thousands of reviews on the internet for its product, which acts as a precious information both for customers and vendors. Analyzing those reviews simply by sentiment doesn't convey the whole picture of the review. It contains information of different aspects of products which should not be neglected. So here comes the concept of aspect-based sentiment analysis. We can extract aspect from a sentiment using A/B assay system. That is, existing review can be extracted in detail. That is why we choose the paper Relation-Aware Collaborative Learning for Unified Aspect-Based Sentiment Analysis. The model is divided into two-step multitask learning and relation propagation. At the first step, multitask learning adopts shared private GUI subtasks, which are aspect extraction, opinion extraction, and sentiment classification. These tasks jointly learn the S-level shared features. After training the feature, the relation information should be propagated to another layer. By the multi-stacked layer, it performs collaborative learning in different sentiment levels. But there is limitation in the paper approach that category term might not be extracted. Suppose a review everything they solved was very disappointing. Previous RACL extract everything disappointed negative, but everything is not clearly defined. Therefore, if we infuse category extraction, category term good quality can be extracted, which is customer really intended. Also, one aspect can have several options. Let's see, the pasta was delicious, but it didn't come out pretty. Previous RACL extract relation pasta delicious and pasta not pretty, but that's not enough to represent customer intention. But if we infuse category extraction, food quality and food plating can be extracted additively. So we proposed the new relation-aware collaborative learning and paraphrasing method using category for A/B assay. The model we propose CRACL is the addition of category extraction to the existing method RACL. As you can see, this model performs aspect opinion, category, and sentiment extraction using its relation in learning. After running through multi-layer, it generates the paraphrased sentence. Our plan was using restaurant ACOS and laptop ACOS dataset to evaluate our model and perform F1 precision and recall score. ACOS data represent aspect, category, sentiment, and opinion according to review. We expect our model to have the following contribution. First, more accurate text analysis is possible because of category extraction. Additionally, more applicable output can be produced. Finally, the paraphrasing model can make the result of text analysis much easier to understand.
Now let's move on to the application and progress part. Experiment settings. The paper used RACL Glove for pre-trained word embedding model and RACL BERT for pre-trained language encoder model. Settings of hyperparameters such as dimension, learning rate, kernel size, layer number, optimizer, all as shown to the slide. These are some specifics of the experiment setting we used during the application. We used the code from GitHub and the packages as follows. We used BERT large uncased model from Hugging Face and used the same hyperparameter from the paper. This is the main result of our application process. We succeeded to get similar results from the paper with an average difference of 0.91% only. Next, we were generating our model CRACL by adding category to the RACL model. There are four main tasks to add category to the existing paper. First, an existing baseline RACL cannot compare the accuracy of the category, so we had to find a new baseline. Second, the dataset was changed to restaurant ACOS, which the category was added. Third, the category is extracted from other terms and the relationship with other terms is obtained. Lastly, it should be added to the part where the existing performance is calculated whether the category is well predicted. Among these four tasks, we performed 1 and 2. There are two main papers that deals with all four components in ABSA tasks ACOS and quad paper. ACOS model introduces a new extract then classify algorithm, and the quad paper works by simply adding opinion tag to existing TAS model. Both papers are meaningful in the sense that they propose new dataset for ABSA tasks containing all 4 components. Therefore, we decided to use these 2 papers as our new baseline, but due to limited storage, we have only replicated ACOS paper, which used up lower resources. For fair comparison, we used the same BERT-large uncased model. We believe that this change yielded a larger difference of the result from the original paper. What is notable is that the F1 score is much lower than the RCL model. We analyzed this result by 2 reasons. First is that ACOS model only considers the relationship between aspect and opinion term, which is much superficial than the RCL model. Also, we think that the low F1 score indicates difficulty of category detection. RCL doesn't include category detection when calculating its F1 score, which would be more advantageous in showing better results. We looked at the dataset used by the 3 existing papers. First, the existing baseline, RCL, expressed the sentence well in opinion and aspect sentiment, while it has the disadvantage of not having category that we need. Next, dataset of ACOS paper were laptop ACOS and restaurant ACOS. Although these data show aspect, category, sentiment, and opinion, this labeling is often inaccurate. In the example sentence, when what a great place is labeled with the 3rd and 4th words great place, and the opinion is labeled with the 2nd and 3rd words are great. Like this, there were many errors because it was directly labeled by humans. Finally, data used in quad paper are RES 15 and RES 16. These are most suitable for data we were looking for. Therefore, we have previously decided to use data from ACOS paper, but instead we decided to use data from quad paper. At this time, the category labeling from ACOS would be more suitable for the preference part of our model, so only the category was changed to that style. The finally changed data is as follows. We have written the process of converting data to fit each model in code and rechecking the performance of the existing model with the changed data. These are some other problems we faced during the replication process. Where there are conflicts between packages that were not specified by the authors of the paper. Also, due to the limited storage of the server, we could not try out different baseline models. To solve these problems, we would like to minimize the storage usage by sharing duplicate files or packages between Conda environments. Also, we are considering to use Miniconda instead of Anaconda to reduce the size.
All right, now we'll talk about our specific research plans. Among the 4 tasks mentioned before, we'll talk about the last 2 tasks, which is extracting category and evaluating our models over performance. What we are aiming to do is changing the extraction algorithm itself. Previous approaches simply use aspect term and opinion term as an input to classify the category of the aspect term. However, instead, what we attempt to do is using a shared private scheme, which is an algorithm proposed by the RACL paper. So this is an example of the shared private scheme. We give input into all 3 subtasks and concatenates the intermediate results to create the shared information. Then the model transforms the shared information and puts it back to the private features, which the model then uses to solve each subtask. We're going to put category extraction inside this model so that each component can communicate with each other in an interactive way. Next is how we are going to evaluate the performance of our model. We'll first measure the F1 score of the category extraction and include that in the calculation of total F1 score like this. So here, there are total 3 ways we would compare our model to the baselines. First, we want to find out whether the addition of category into relation would positively affect the F1 score of other components like aspect, opinion, and sentiment. So this table shows the results of an existing RACL paper. As we said, we are going to add the F1 score to measure the performance of category extraction. After that, we'll compare the performance of our CRACL Globe and BERT model to existing models to see how adding categories can affect the performance of other subtests. Next, we would like to find out whether our model performs better than other baseline models for the entire ASQP test, which will be ACOS and quad model. These are the new models, new baseline models for the ASQP test as we introduced in the replication part. And then we'll calculate the same precision recall and F1 score for our RACF model, and then find out whether it has improved or not. Finally, we would like to test whether our model works better for implicit expect or opinion problem, which it was in the prevalence statement in our introduction. This will be done like this table, which is from the ACOS paper. This is our concrete roadmap for the remaining semester, and thank you for listening for our presentation.